Hi students, welcome to my lectures on mechanical unit operations. Today we are going to discuss about the topic called filtration. And this filtration is of many uses in the industry. So it is very important for us to design a filtration unit. That means for a given capacity, how much area, how much pressure we have to use to filtrate the system. Today we are mainly going to discuss about the constant pressure filtration setups. For example, what is the constant pressure filtration setup? The pressure that is given to the filtration unit is the same. Suppose if I give 3 atmosphere pressure, from starting till end of the operation, I am not going to change the pressure that is generating from the pump. Okay. What happens in such cases? In constant pressure filtrations, what we observe is the filtrate, that means the water that is coming out of water or any other medium that is coming out of the filtration unit, the flow rate will reduce with the time. Why? Because as the filtration is happening, more and more particles or cake will deposit on the surface. With the time, if more is the deposition on the surface, the outlet, the water that is coming out of this filtration unit, the flow rate will diminish with the time. Okay, that's what the constant pressure filtration. And typically in major industries, people use the constant pressure filtration, and let us derive. So what is the main objective today? To design any big filtration system, we need two things. One is, what is the resistance? In any filtration setup, there are two resistances are there. One is cloth, which we use to filter the slurry, and second, initially it will be cloth only, where slowly the cake will deposit on the filter cloth. That means initial resistance that is offered, that the fluid is facing, is only the cloth resistance or medium resistance. After certain point of time, the cake will be deposited, and second, the additional resistance that is offers, that is the cake now. Because more is the cake, more is the resistance that feels by the liquid while passing through the cake. In reality, the medium resistance is negligible compared to the cake resistance, because the medium resistance is very narrow, very small compared to the cake. So in general, in filtration problems, generally people try to neglect the cake resistance. Okay, the objective, once you know both the resistances, cake resistance and medium resistance, and our chapter is done in the sense. That means if you know the cake resistance, which is alpha, medium resistance, which is Rm, then you can design any filtration unit. Okay. Because these are the more important parameters in designing the filtration unit. So let us go to the board. Assume this is the filter press. This is the thickness of the medium, that is filter cloth, and this is the cake. L is the length of the cake that is deposited on this medium. The pressure, inlet pressure, that means from the pump we give certain pressure, right? That is PA. This is PB, that is outlet pressure. That means if it is open to atmosphere, PB is 1 atmosphere. If that is the cake, and we have to find out what is the resistance offered by this cake and what is the resistance offered by this medium. Once you know both the terms, we can design the filtration unit. So PA, it is P dash, it is PB. PA minus P dash is the pressure drop in the cake. P dash minus PB is the pressure drop in the medium. What is the overall drop? Delta P is a PA minus PB is nothing but PA minus P dash plus P dash minus PB. That is what the total pressure drop over the entire filtration unit is contributed by these two people, cake pressure drop and the medium pressure drop. The cake pressure drop is PA minus P, and the medium pressure drop is P dash minus PB. Delta P is the overall combination of cake and medium. Okay, the objective, remember our objective. Even though derivation is very lengthy, our final objective is to find alpha, which is the cake resistance, Rm is the medium resistance. That's what the whole objective is, to find out alpha and Rm. To start with, we know the pressure that is whatever the pressure drop that happens because of the cake or particles that is deposited over here. If you remember my earlier lectures, okay, the pressure drop in a packed bed, it's just a kind of packed bed only, right? Some pack of materials is getting deposited on this cake. There I told you 3 equations: Kozny-Karman equation, Burke-Plummer equation, Argon equation. The Kozny-Karman equation, majorly the flow is less, viscous forces, and Burke-Plummer equation is used when kinetic forces are high velocities are there inside this cake, then use the Burke-Plummer equation. If viscous forces and kinetic forces both are dominant, then we go for the Argon equation. Let us assume, because there is a huge bunch of cake that will be deposited in the filtration unit, let us go only the velocities are very low. In such cases, let us take the pressure drop in this cake will be estimated using Kozny-Karman equation. The Kozny-Karman equation, as we already seen, delta P by L is equal to 150 into V0 is the superficial velocity, viscosity, porosity, sphericity, particle diameter, and we have to, which is delta P by L is nothing but dP by dL. If we take small differential cross section, because this is the length, if you do the mass balance or pressure balance over this differential length, and this will become delta P by delta L, that means pressure drop over this length will become dP by dL. Okay. Let Vp is the volume of the solids in the cake. You can see Vp is the volume of the solids in this cake, total volume of the particles. Because I have to substitute V bar P is equal to total volume is nothing but area A into length, that is the total volume. In this total volume, what is the volume of the particles? That is total volume into the 1 minus porosity. Because epsilon is a porosity, these empty spaces, and 1 minus epsilon is the occupied by the particles. So volume of the particles A into L into 1 minus epsilon. And if I know the volume of the particles, I know the mass of total mass of the particles in the cake is equal to V bar into rho P is the density of the particles. Then V bar P is equal to m by rho. Simply we substitute here, we get m bar P is equal to rho P into 1 minus epsilon. Then total mass, but we have to take the mass in this differential section, that is dmp bar. Okay. If you differentiate this equation, everything is, density is constant, area is constant, 1 minus porosity is constant, only these both are variables, then dmp bar is nothing but rho p a 1 minus epsilon into dl. From this, dl equal to dmp bar by rho p into 1 minus epsilon. Simply we have to substitute, in place of dl, substitute this entire term. So that's what here, dp, but in place of dl, I substitute the entire equation, and I separated pressure term on one side, other terms on another side. You can see these are all constant because I have to integrate the system now. From what pressure? From this pressure to this pressure, right? PA to P dash or P dash to PB. PA because higher to lower pressure, that is PA is the higher, PA to P dash we have to integrate. Okay. In such cases, at this particular place, what is the mass? Is total mass is mc, because this much amount of mass is deposited. At P dash, what is the mass that is deposited? That is 0. That's my, at PA, the mass is m dash P or mc. Okay. At pressure P, what is the mass that is deposited? At the initial test, there is no mass, as this is 0. So I have to simply use some specific terms. Superficiality velocity V0 is replaced by u now. Okay, because in major books it is represented by u, so I have changed the terms here. Okay, then if you integrate, you get this equation, right? PA minus P dash is nothing but delta PC, that is pressure drop over this cake, is nothing but the entire term. So if you use this and put alpha is equal to 150 into 1 minus epsilon into phi a square dp square epsilon cube into rho. So I have, this is one more term, this is mc is there. Okay, yeah. And sixth, put alpha, this is called the cake resistance. This entire term is represented in the books, is called cake resistance. So if you put alpha in place of here, PA minus P dash equal to delta PC into alpha into mu u mc by a. Okay, u is the superficial velocity, mc is the mass of the cake that is deposited. Okay, and let us go to the other board. Yeah, if I delta Pc by u into mu is nothing alpha into mc by a. Okay, This we have got, okay, what is the pressure drop that happens in the cake. Next is the what is the pressure drop that happens in the medium. By similar analogy, because in general resistance offered by the medium is negligible compared to the cake. So people came up with this, some kind of analogy kind of, see if this is the equation for cake, this is the pressure drop that is happening in the medium, where Rm because is equal to resistance offered by the medium, okay, by analogy, very simple analogies. In general it is negligible in case of realistic situations, still we take it for the derivation purpose. Now I know total delta P is equal to delta Pc plus delta Pm. I know what is delta Pc, I know what is delta Pm, substitute in this equation, I get this equation term. Okay, now I have to get, because in experiments I measure what I can able to measure with the time, how much amount of volume that is collected in my filtration unit, through which I have to find out medium resistance and cake resistance. So let us get those terms, time and volume terms. I know velocity is nothing but volumetric flow rate divided by area. So dV by dA, V is the volume, T is the time, A is the area of the filtration unit. So if you substitute in place of U dV by dt into 1 by A, I get volume and time terms, okay. If we substitute in place of velocity dV by dt into 1 by A, I rearrange the terms, this is the dt by d, and you reverse this equation. I mean, if you rearrange this equation in terms of dt by dV, you get dt by dV is equal to mc alpha by A plus Rm into mu by A into delta P. This is the equation popularly used in designing the filtration equations, okay, main equation in place of differential form. Now let us remove the differentiation by putting the integrations. Equation 12, okay, let us integrate, because what we are doing is measuring, I mean, constant pressure filtration, that means delta P is equal to constant. In such cases, how my equation look like? Simple, dt on one side, dV on another side, and integral 0 to t time, volume this collected 0 to V, okay, simple integrate, okay, where mc, here the mc, mass, is nothing but concentration into volume, right. Concentration is you can, I mean, meter cube per, I mean, you can see concentration into volume, you get the mass, okay, kg per meter cube into meter cube, meter cube cancels, you get the mass, okay. Simply we have to substitute in place of mc, you get C into V, okay. C is the concentration and delta P equal to constant. Now let us integrate, okay. Integral 0 to t dt is a t. Here we have integral 0 to V, V dV, 0 to V and dV, okay. If you apply the integration, you get this equation. If you rearrange this equation, you get T by V is equal to mu C alpha by 2 into A square into delta P into V plus mu Rm by A into delta P, okay. And if you keep this mu C alpha A square into delta P as a Kc, mu Rm by A delta P as 1 by Q0, you substitute in this equation, you get T by V Kc by 2 into V plus 1 by Q0. This is the equation popularly used for the constant pressure filtration setups. And if you see y equal to mx plus c form, okay, T by E equal to y, Kc by 2 is equal to slope of this equation, V is equal to x, 1 by Q0 is equal to intercept. That means I can get the values of Kc by 2 and 1 by Q0 if you may know the slope and intercept of this equation. How I can get? If I plot T by V on y axis, V on x axis, I get some curve. From the curve, I get the slope Kc by 2. From the intercept, I get 1 by Q0. That is why slope is equal to Kc by 2 into mu C alpha by 2 into A square into delta P. From this, what is my alpha? My alpha is equal to slope into 2 into A square into delta B by mu into C. What is my intercept is equal to 1 by Q0, which is a mu Rm by A into delta P. From this, Rm equal to intercept into A into delta P divided by mu. This is my final equation. So I have arrived to the conclusion. That means doing all this mathematics, finally I get to know only two equations from which I can able to calculate the specific cake resistance, which is alpha from this equation, and medium resistance Rm from these equations, okay. That means if I know the slope of the curve. That means if I do some experiments, I get the time versus volume, right? How much time, what is the volume of the filtrate I have collected from the filter press or any filtration unit. If I plot those T by V versus V, from that you get a slope and intercept. From the slope and intercept, laboratory experiments, I get alpha and Rm. If I know the alpha and Rm, I can design big filtration units, because I have conducted experiments in small filtration units where alpha and Rm I do not know. From the small setup or laboratory setup, I know the values of alpha and Rm. Once I know the alpha Rm, I can design a big filtration units. Let us do a small example on how to find an alpha and Rm given some data. This is a problem. There is some filter press or filtration unit where the feed is going, the particles or cake got collected here, and the volume of the filtrate, that means pure water or anything, is getting collected. V is the amount of volume that is collected with respect to time, that means time t equal to 0, 0 volume, time t equal to 1, this much volume, time t equal to 10 seconds, maybe this much volume. Like that, I have some data with me. Given this area available for the flow or filtration area given 440 centimeter square, this much meter square. The concentration of the slurry which I have to filter is nothing but 23.5 kg per meter. There is a concentration of calcium carbonate, it could be anything. Viscosity of this solution is given. Okay. Delta P, that means how much PA minus PB, delta P, that is how much pressure I have given with this particular pump, is given 6.7 lb force per inch square. If I convert lb force per inch square to Newton per meter square, 4619 4.81 Newton per meter square. Given this data, tell me what is the resistance of the cake and what is the resistance of the medium. These are the laboratory experiments. That means, and time is because I have started doing some experiments in the lab, I have collected some volume of the filtrate with, that means I am collecting some volume here with respect to time. Time 17.3 seconds, I get 0.5 liters. At 41.3 cumulative, this is not a differential, okay. 17.3 seconds, I got 0.5 liter. And the time is 41.3 seconds, my volume is 1 liter, okay. At 72 seconds, 1.5 liter. That means I have started collecting the volume with respect to time. This is the data, okay. I know volume, I know seconds, I know T by V, but it has given in liters. You better convert it to meter cube so that we can consistently following SI units in this entire lecture series. So I know the T by V versus V. I plot T by V versus V. I got some data points. From the data points, I draw a line connecting majorly of all the points. I get the slope and intercept. From the slope and intercept, this is how I calculate a slope. Okay, when you do personally you do the calculations. By you get the slope, you get 1.3 into 10 power 7 per meter cube, the unit of the slope. And alpha, you have to calculate the cake resistance, the slope into 2 into a square delta P by mu into C. So if you put all the values, you get alpha equal to 1.529 into 10 power 11 meter per kg. And if you know the intercept, Rm is equal to medium resistance, the intercept into A into delta P by mu. If you put all the values, you get medium resistance is 6.4 into 10 power 10. Okay. This is how, once you know the alpha and Rm for the specific slurry, you can design the big filtration units. Okay. I hope you have learned well, and thanks for following my lectures all the time. I have covered major topics in this mechanical unit operations. Hope I will meet you soon in the next vacation or June, July. I will come up with a new subject. Till now, whenever I find time, I will try to make videos. And thank you very much, students, for your support and encouragement. See you.